Hello everyone and welcome to another stream. So if you don't know me, my name is Luciano and I've been streaming for a while, probably the last couple of years, probably around once a week, about my learning journey with Rust. I've been doing a lot of advent of code, I've been doing some experimental game development, which went pretty badly in my opinion. Lately we've been doing some web servers, and today I want to try something a little bit different. But before we get to that, let me share my YouTube channel where you can find all the recording in case you're interested in looking at the previous episodes. And I'm gonna drop that even in the chat. And yeah, we'll be ready to start in a second. Okay, so what do we want to do today? Let me share my screen so I can probably explain that a little bit better. Alright, so you should be seeing my screen and my editor, but before we get into the code, let me show you this website that you may or may not know. It's called Last.fm. It's a website I've been using for quite a while, probably more than 10 years. And yeah, it says here 12 February 2007, so getting close. Basically, it's a website where you can install a plugin for your music player, Spotify, whatever, and it records everything you listen to, and it's a nice way for you to see statistics about your musical taste. It's gonna tell you if there is a concert of the bands you like in the cities where you generally go, and it also gives you advices on music that you might like. So I'm really into music, I always listen to music. And one thing that I was thinking is that it would be nice to, in my website, to have a little widget that shows if I'm listening to something at that moment, what is that song. So today I want to use an API that Last.fm is going to give us and write some Rust code that allows me to do effectively an HTTP request to that API, get the information that I want, and maybe in the future I can use this code to build a Lambda, and with that Lambda I can then invoke it from my own front end and get the music displayed on the website. Okay, so where do we start? Let's have a quick look at the API. And you are warned that this API is a little bit messy. I think this API is probably one of the very first APIs that I've seen, so also quite old. And as you can see, it even supports XML, which is quite telling for how old this API is. And yeah, there are a bunch of different methods. You need to have an API key, so we're going to look into that as well. But there is one particular method that I like, and by the way, this is quite of a RPC style of API, like you need to specify the method here in the URL. So yeah, you might have seen this kind of APIs, this style of APIs some time ago. Definitely not a RESTful type of API. So the one method that we are interested in calling is this user get recent tracks, which basically is going to give us a response that looks like this. And don't worry, we can even get it in JSON. We can specify a user. For instance, here we have this user called orj. And for this particular user, we can see that it's currently playing a specific song, and we get all the details of the song. So we get the name of the song. We should get the artist, there it is. We also get a URL that we can link on Last.fm. And I think that if we use the extended API, if I remember correctly, yes, there is here a parameter called extended. I believe that if we use this one, we can also get a URL with a picture for the album. Let's see if there is an example with that. Not really, so I suppose we will have to try that for ourselves. So yes, basically what I want to try to achieve today in about 1 hour is trying to, in Rust, do an API call to this API and somehow process the response. So let's see if we can do it in 1 hour. Now, there are a few things that we will need to do first, because this API requires you to have an API key. And of course, I'm not going to display on stream the API key. We are going to be using this crate, which I never used before, so also a little bit of an experiment. And this crate is called dotenv, and this crate should allow us to load environment variables from a file. So I have prepared a file. Right now it doesn't contain the real API key. So we will try to make this crate work, load the environment variable. When it's working, I will secretly swap the fake API key with a real one, and then we will continue implementing our HTTP request. For the HTTP request, I will try to use this other crate called reqwest, which is asynchronous HTTP client. So it needs also Tokyo as an asynchronous runtime. So we will also try to use all of that. And probably because we will need to parse some JSON, I expect we're going to need to install also serde and serde-json. So if all of that looks good to you, I will say let's get into it, but feel free anytime to drop questions in the chat, which right now is very quiet. So if you're there, please just say hello and where are you connected from. And yes, let's try to do this together. And as usual, my disclaimer is because I'm terrible at Rust, if there is something that you believe I'm doing wrong, feel free to tell me. I'm here to learn more than to teach. That's for sure. So let's do it. Okay, so the first thing that I want to do, I'm going to go and do, actually, I want to try to switch to this experimental view. So if it is too annoying, let me know and we will change into something else. So yeah, you should see me in this kind of background with code above me. So let's see. If you don't like it, let me know. Okay, so let's start by installing this cargo.env. And when this is done, we will switch to the editor, which I have somewhere here. Actually, let me copy a piece of code from here, rust.env. It should be, so basically I have already created a file called .env. Let's look at that. Somewhere here, I have a .env file that says lastfm API key equal fake key. So this is what we will replace later, but hopefully we should be able to load this environment variable from a file. So how do we enable it? We need to say external crate.env, use .env, and then in our main, we just need to say .env.ok. And at that point, this should load environment variables in our process. And then how do we read environment variables? With this for loop. Oh, we have WGaffa in the chat. How are you? Good to seeing you here. We also have Dario Web Dev. How are you, Dario? Nice to have you here as well. Dario is saying that he doesn't have any knowledge about Rust, but let's see it in action. Will be interesting. I don't have a lot of knowledge about Rust either, so let's see about that. So for now, I'm just going to copy all of this code. So let's go back to the editor, replace everything we have here. And if everything works as expected, we should see our environment variable. Ooh, we have lots of environment variables, so I'm going to kill that. And actually, we're just going to get the environment variable we care about. So let's say let lastfm API key equal env var lastfm API key. Perfect. Thank you, Copilot. Is also giving us a nice way to manage the error. And then what we can do is print lastfm API key. Now, if this is working, what we expect to see is fake API key. Perfect. Okay, that's good. You can see here that this is working. Yeah, WGaffa is saying he didn't know I stream on Wednesday. I generally stream on Mondays, but because I skipped the last couple of Mondays for personal reasons, I was feeling a little bit guilty, and because I have some time today, I decided, okay, let's just improvise a stream. I hope that this day works for you. I might be doing it a little bit more in the next few weeks, but let's see how this one goes. Okay, so at this point, what can we do next? I suppose the next thing we can do is to try to install the HTTP request library, request, install Tokyo, and let's try to do this particular API call and get a simple response. So let's go to this other API, this other crate, sorry. We need to add this to our dependencies list. So the way you do that is either with cargo add, or you can just copy paste your dependencies here. Now we should have Tokyo and request. What do we do? Let's see. Let's try to do this one first and integrate it in our example. So I know I have two main functions here. This is of course not what we want to do. So I'm just gonna copy paste this one for now, kill this one, and we can do this one here. We are not gonna use this API key for a second, so let's ignore that. So at this point, what we want to print is this response. So basically what this is doing is, actually, let me do a step back. This is an async function. In the Rust, unlike JavaScript, you have to be very explicit to use async await, meaning that there is some async support in the language itself. For instance, async is an actual keyword that makes sense for the language, but the way that the async runtime is implemented, it's a little bit up to you, meaning that you can use different runtimes, and it's up to you to pick a specific runtime that actually implements that async functionality. And I believe that the reason why they do that in Rust is to allow in different situations to use runtimes that might be more suitable for that situation. For instance, if you are in an embedded system, you probably want to use a very lightweight runtime, maybe with less features, maybe it doesn't do allocations. But if you are building a web project, maybe you want to use something like Tokyo, which is much more feature complete, and it can do a lot more things than maybe something that is optimized for embedded devices is not going to be able to do. So that's why we installed this Tokyo. And the way we use Tokyo is basically to say, because a main function on its own theoretically cannot be async, it just needs to be a regular function, we can use this particular annotation, which is effectively wrapping an original main function, creating an async executor, and then executing all this code for us in an async context. I hope that I am explaining that somewhat correctly. Don't take my words for granted, because as I said, I'm not extremely experienced with Rust, so I might get some stuff a little bit wrong, so take everything with a pinch of salt. At this point, we should be able to run this, and if we did everything correctly, this is gonna initialize a client, a request, is gonna do a GET request to this URL, which definitely not what we want to do, but it's probably good enough for testing. Then it's gonna await for that request to finish. Then at that point, it's gonna, this first await basically means that you got the response headers back. Then the second thing is, how do we process the response body? And this is probably saying, I want to process it as a JSON, and I want to collect that JSON information into an hash map, which is just a dictionary if you want. And this hash map is specifically mapping keys as string and values as string. And then the second await is required because receiving the body, the response body, is not necessarily a one-off type of operation. It's another asynchronous operation. It might take a while for the entire body to be downloaded from the server. So we will need to await for the headers, decide how to parse the body, await for the entire body to be fully parsed. At that point, we should have a response, and we are just going to print this response. And OK is because this particular main returns a result, and a result is just a way in Rust to say this entire operation could fail. If it doesn't fail, it returns this thing, which is just what is called unity type, I believe, a unit type. So it's basically like an empty tuple. It's a way to say nothing. But if it fails, it's going to return this particular kind of error. So we need to say OK, because this particular method is expected to return something. In case of failure, we use this question mark annotation, which basically says if this await operation fails, bubble up the error and return a generic error there. Again, if that doesn't make any sense, or if you have questions, feel free to shoot them in the chat, and I'm going to try my best to reply or to use Google to try to find an answer. Let's run this. It's taking a bit long because it's downloading all the dependencies since it's the first time that we are running this code after having installed request and Tokyo. And you can see that there are a lot more dependencies, and this is because probably request and Tokyo, they have transient dependencies, so they are also bringing their own dependencies. And now you can see some sensitive piece of information, which is my IP address. So I don't know what you can do with that, but whatever. This seems to be working. Sounds good. So now let's try to do the last.fm actual request. So let's do a few things. So actually, this is an interesting question. I don't really know if there is a nice way to construct URLs in Rust. Maybe we want to do a quick search and figure that part out. So if you know any good crate to build a URL programmatically, because eventually what we want to do is to say there is a very specific base URL, then there is a set of query string parameters where we specify the method, the API key, user, bunch of other options. At the end of it, we want to get a URL as a string, and that's what we want to pass here. And at that point, we should be able to do a generic request. Okay, let me actually, while we do that, I want to do something else first. I want to parse this rather than as a JSON in an hash map. I want to get a raw JSON object using serde and serde-json. So I want to install those as well. But while I do that, again, if you know any good way to build URLs programmatically, drop it in the chat. I'm gonna appreciate your help. Okay, so let's go here and let's search for Rust, serde, and let's have a quick look at that. So basically serde is a serialization, deserialization library for Rust. It's, I suppose, the most common for what I've seen. And it supports a bunch of different formats, including JSON. So generally you install serde, which is kind of the core library that implements generic traits. And then you install a more specific crate, which gives you a specific implementation. For instance, JSON, CBOR, YAML, TOML, Pickle, Bison, JSON5. There are so many formats that are supported there. And generally the way you use it, you could do two different things. One might be familiar if you have seen some Java, I suppose, and if you use something like Jackson, where basically you define your own type, let's call it this way in generic terms, and then you say whatever is the structure in JSON, map it to this particular type. There is another approach when you use serde-json, and we are going to go to the documentation of serde-json in a second, which is you can get a generic JSON object, and a generic JSON object is just an enum in Rust, which can be either a dictionary, so an actual object, either a null value, either an array, a string value, or a number, or null, I believe, which are all the types that can exist in JSON. And these types are, for instance, recursive, because if you get an array, that's an array of JSON values. So it could be an array of arrays, an array of null, an array of mixed values, some null, some strings, some numbers. And similarly with objects, you will have an object where you have keys and values, and the value part could be another JSON object type, could be a null, could be an array. So this is how you could basically decode very generic JSON, and you end up with a tree of enums that you will need to parse on your own. And because we don't really know exactly what's going to be the response of this particular API, well, we could know that, but let's pretend we don't know by just looking at the documentation. We want to parse it in a very generic way and then based on that parsing, maybe we will create a proper struct to just make our life a little bit easier. Okay, we have a question in the chat by Akdakdakd. Sorry, that's a very good nickname and I cannot pronounce that, so apologies. So the question is, do you work exclusively in Rust? Is this showing up? Okay, do you work exclusively in Rust these days? Would you recommend learning it for a Node dev? So it's a very good question. Actually, it's a good question for me specifically, because I am actually coming from a very strong Node.js background, and I've been learning Rust for the last 3 years, more or less, but I haven't used it yet in a production project. So learning Rust, I think, has been extremely beneficial for me, because the model that it brings, it's a very interesting model. It kind of pushes you to think in a slightly different way from what we are used to, especially coming from a higher level language like JavaScript. So I think it's definitely a very good exercise to try to learn it, because I think you are going to come out with a much more complete knowledge of programming and software engineering. There are lots of things that I like, for instance, the result type, the option type, which are concepts that after I am learning them and using them in Rust, I wish they existed also in other languages like JavaScript and Python, that I use a lot more for my work days. So I definitely recommend looking into Rust. Hopefully it's going to become more and more common, so there will be also more chances to use it in real life projects. I'm hearing more and more of real life projects, so it could also be a skill that gets very valuable in the market. So keep that in mind, and if you do it, let me know how it goes. And yeah, feel free to come by in the streams and chat, and maybe we can keep learning together. I hope that answers your question, but feel free to ask for clarifying questions if it doesn't. Okay, so where were we? So we wanted to install serde and serde-json. So let's go to the documentation of serde-json, which should give us a few more details on how to install it. Actually, it doesn't give us much. So let's just do this. Let's just do cargo add serde, and then cargo add serde-json. Oh, I think I'm doing the same mistake again. Okay, let's... I did this mistake the last time in the last stream, so WGaffa might remember this, because you also gave me a shortcut which I cannot remember. But let's fix it this way. Let's do features. Is it derive, or do we need all? I think we can just do all, right? Or it doesn't have all. Let's see. It doesn't have an all, but it does have derive, which is what we want, I suppose. And then serde-json, what we want, probably just standard is fine. Okay, so let's go with it. Let's assume that this is fine. So what we want to do now is to basically say use serde-json value. Value is the generic type. And now what we want to do, and I hope this is going to work, is to just say value. And hopefully now the output is not going to change, but here we are processing that the type of this guy is not an hash map anymore, but it's a generic JSON value. Oh yes, thank you, WGaffa. Is saying that it was called cargo add features, which you told me last time, because when you do cargo add from the CLI, you can also specify the list of features that you want to use. So it's gonna basically populate this value. For instance, for .env, we are not using any feature, so you can just do cargo add .env, and it's fine. It's gonna add the last version. But for instance, here in request, if you wanted to use features JSON, you needed to say cargo add -- features in JSON. I just copy pasted it from the docs because I couldn't remember that CLI argument. Okay, back to our response. Here we got this object, which we didn't see before, because before we had a generic hash map. And this object is telling us, okay, the response that we got is a JSON object. It contains key value pairs because it's a JSON object. The key is origin, and the value, by the way, is a string, and this is the value for that string. So the output is slightly different because we are getting a lot more information about the types. It's not trying to convert the types for us, but it's sticking to the original JSON types that we got in the JSON response. Sounds good. We are getting closer to our objective. Okay, so we said we wanted to figure out a way to build URLs programmatically. So probably here we will do something like let base URL equal whatever that is. We are going to check in the documentation, which I have here on the side. So this is the base URL. And basically what we want to do programmatically is add query parameters, and we want to add something like API key equal X. We want to add method equal. We should know that. We did see that a second ago. User get recent tracks, which needs to be all lowercase. Actually, we can copy this one probably. So yeah, we want to add this method. We want to add the user, which in my case is going to be, guess what, Loige. And API key is already here. And finally, we want to specify format JSON. So how do we do all of this programmatically? I guess we have to Google that. I didn't get any suggestion from the chat. Shame on you. Okay, Rust, how to build URLs programmatically. I'm sure there is like a URL crate or something. URL dispatch. URL is the best one I can think of. Is that built-in module? Rust URL crate. Let's see. URL library for Rust based on the WGaffa standard, or whatever you pronounce that. What WG I'm gonna call it. Let's check the documentation. What does it do? Okay, this seems to be able to parse. Can we also construct a URL? Let's see. I mean, we can also do string concatenation. That's, I suppose, reasonably good enough because we know we're probably not gonna have weird characters that needs to be escaped, but I would prefer to do it a little bit more cleanly if possible. Okay, there is a join method there. Let's see, structs URL. In URL, what can we do if we do a mutable URL? Is there an example here? Parse with params. Oh yeah, nice. That seems what we want to do, because it's passing a bunch of extra parameter as key value pairs, and it's getting a full URL. Okay, I like it. Let's install this crate. Sorry, I just realized now that WGaffa was giving me very useful pieces of advice. Thank you for that. And I totally ignored the chat. there is a few set methods, but I think this one is going to be good enough. So let's give this one a go. So I'm gonna copy paste this one for now. And also we want to do cargo add URL. Nice. Sounds good. So we want to use this base URL first. And then here we can specify all the different parameters that we want. So we want to pass the method, and we know the method value. We want to pass the user, which could also be an environment variable, but for now I'm just gonna hard code it. Then we want to specify format JSON. Oh yeah, there was another one that we wanted to try, extended equal 1. And then we need the API key. API key, we do have that one here. Okay. And I think that's it. We need to import this particular trait. Oh, there was a request URL. Interesting. So maybe request had the same crate already built in. Okay, let's ignore this for now and let's just do use URL. And now let's just do print println URL, and let me comment this one out for a second. Oh yeah, of course. Copilot hasn't really caught up with this new shorter syntax. Okay, so let's run this code. What's going on? So do we get... Oh yeah, we do get a URL like this because I just printed the object as it is in debug mode. What we want to do actually is to say, is there a URL toString? toString, yeah, let's do that. Okay, that looks like what we want to do, and it's showing fake key. I haven't replaced with the real key yet. So let's actually let this fail. Let's use this here. And we expect that the response is going to be something like, you have the wrong API key. Fingers crossed. Perfect. So the response object is error. You can see that this type is a number. It's not a string. So this is because it's an actual JSON number and not a JSON string with a number inside. And then the message is invalid API key. You must be granted a valid key by Last.fm. That's really good. So what I want to do next is basically secretly in another screen, I'm gonna swap my API key. So you have to trust me on that. And we're gonna try again. And let's see if we get a different response now. Nice. We are getting a much bigger response. So this is kind of working. Wow, such a big response that doesn't even fit my history. Let's do it in the terminal. Let's do cargo run. Okay, now we should be able to scroll back because I have a longer history here. Perfect. So how does it look like? It looks like an object. The first attribute is recent tracks, which is an object. Then this object contains another object called at attributes, which contains generic attributes like number of pages and so on. Oh wow, this is how many songs I have been listening to since I joined Last.fm. So almost 300,000 songs. I don't know if that's a huge number or not, but sounds like a lot. Okay, perfect. So what is the most recent song that I listened to? Is that the most recent or the first one ever? So this is an album. So this is the album where the song is from. Then we have the artist, which is, by the way, here we get all the pictures even for the artist, which is quite interesting. Actually, I'm curious to see this one. So let's go in the browser. Oh yeah, they don't have a picture for this particular album. I suppose this is just the standard one. Okay, let's try. Yes, this is probably the last song I was listening to. There is a URL. There is a date, so 8th of February. This is the time. Okay, sounds good. Okay, so what do we want to do next? I think that one thing that might be interesting to try is, rather than using this very generic JSON parsing, to try to actually parse it into a custom struct. So we will need to try to define this custom struct and apply all the serde annotations to basically tell it what to do. So this might be a little bit of work. I don't know if we are required to specify every single field. So for now, I'm just gonna copy one track just as a reference, but we are not gonna implement all these methods. Oh yeah, here there is another picture that we might want to try. This one. Let's see if this one is more interesting. Yeah, perfect. So we can also get the album cover if we wanted to. Okay, so sorry, let me do this again. Let's stop at here where we have another object. Okay, so I'm gonna do, how do we do this? Let's do a new file. Let's put it on the side. And let's just put this one here as a reference. Okay, so let's start to define our own types. Let's say that we have struct recent tracks, and this one contains recent tracks, which contains recent track data. Thank you, Copilot. Now struct recent tracks data contains track, and it's a vector, an array of tracks. So let's define struct track. Ooh, I'm loving Copilot today. Let's see how close it's getting. So every track is an object that contains an album, which we're gonna have to define. So there is a little bit of work to do there. Then there is an artist, which is an artist. Okay, then is there a name? No. Oh yeah, there is a name. Nice. There is a URL, which is another string. There is this MB ID, which we can also add it as another string. Then there is a date. Date here it's, okay, this one might be a little bit tricky, I suppose. Let's call it Last.fm date for now. Okay, artist, we mentioned that. Okay, now we need to have fun and implement all these other ones. Keep in mind that I am intentionally skipping this attribute section because I don't know, I don't think it's interesting for now, and I don't believe we need to explicitly have all the fields. I think serde is just gonna populate the ones that we have. So let's do the other one, struct artist. Let's see how an artist looks like. Artist, we have an image. We could even create the image type, to be honest. So struct image, and image is an object that contains text and sides. How do we specify text with that hashtag? Is it like this? Okay, and sides. Sorry, this is double quotes, or is it just or? Yeah. Okay. There might be an annotation in serde to keep this as text and just say whenever you are deserializing, look for this particular string. We'll try to fix this in a second. So an artist has a set of images. So image is a vec of image. Then there is a name, MBID, and URL. Okay, so what's left? We have an album. And an album as, nope, this time Copilot is not quite right. An album just has text and MBID. So we have row text, which is a string, and MBID, which is a string. And we only need this lastfm date, which for now I'm just gonna date as text, and UTS for now let's just keep it as a string. It might be nice to deserialize this as a proper datetime object, but for now let's just keep it simple. What did we do wrong? Okay, perfect. So now we have all these types here. Let's just hide this one for a second. But all these types are just plain structs. They are not really doing anything. In order to make them something we can deserialize from JSON, we need to add some serde annotation. So let's go to the docs and let's double check that. Meanwhile, I don't know if everything I'm doing makes sense to you. Feel free to shout in the chat if you have specific questions. Okay, here for instance we have an example, piece of JSON. How do we operate? This is the generic enum value, the one that we are using right now. So you can see that contains all the different types that you can have in JSON, and these types can be recursive. For instance, an array can contain, is effectively a vector of other values, so a vector of anything like this, while an object is a map of strings and other values, so it can map strings to any other thing like this. Now this is just parsing as a generic piece of JSON, but this is what we want to use, serde-deserialize, and we can use this derive macro to basically say make this particular type something that you can populate from raw JSON. So this is what we want to do in our own code. So we want to use this, and now everywhere we want to say derive deserialize, and because I'm quite sure we'll need this, I'm also gonna derive debug. Okay, sorry, was re-enabling the do not disturb mode. Perfect. At this point, if I understand this crate correctly, what we can do is to just say use this recent tracks method, and now rather than deserializing to a generic value here, we can say this needs to be a recent tracks, and here we can just do, I suppose, this. So we're basically saying now I want this type out of whatever JSON you can get from the response, and serde should try to deserialize all of that for us. Are we confident that this is going to work? Let's see. Of course, we don't need this anymore. I don't know why it's complaining. I suppose because we are not accessing this directly. So let's try to run the main. Ooh, did it explode? Missing field text. Oh, where is it missing? Right, I suppose we will need to learn more about how do we skip fields that we don't want. I wish that this guy was telling us. Line 1, column 230. Okay. Let's not lose our confidence. We can do this. How do we deserialize and ignore fields? Because what we did here, we definitely ignored, for instance, all this block. So serde might just tell us, what the hell is this? Where do I put it? Do I just skip it? And we just went straight for recent tracks. So let's go back here. Do we have a documentation for serde? Serde API documentation. Macros. Serialize, deserialize. Okay, let's go to deserialize. No, this is not what I'm looking for. I'm looking for, let's see what we have here. Oh wait, this is just the serde one. We want the JSON one. Okay, so what do we have? I wonder if we also need to implement serialize. I don't think so. But let's keep that option open. So we can construct a generic piece of JSON. Hey, Geldi Scuba, thank you for the follow. If it's the first time you are following the stream, hello. I'd love to know how did you find it. And yeah, if you want to introduce yourself, I'd love to hear that too. Okay, so still not sure. Serde-json. The serializer, yeah, does it give us anything? This is just raw deserialization. I'm making a big assumption here, and maybe you can give me some help. Basically what I'm trying to understand is that maybe there is a way here to say ignore other fields with some kind of annotation like this. So this is what I'm looking for here. What are all the possible annotations that you can use with serde-json? Where do you see all the serde-json skip? Okay, here you can skip serializing. Maybe we should look at this documentation. This is probably more useful. Using derive. I think we have added this particular feature, so let's make sure that's being used. If we go to our cargo toml, we do have features derive on serde, so that should be good. So similarly, input use serde deserialize, derive deserialize. What do we want to do here? Deserialize and debug. Okay, I'm just gonna use serialize just in case. Let's remove that particular question. And what we want to do is every time we use this, let's also add serialize. Let's see if that makes a difference. I don't expect so. So request error kind decode missing field text. Right, I want to try to do another thing. Let's just do for a second something. Let's copy this and let's do this as a string. Is there text? Right, so now we should see the response as a string. Cool, this is the raw response, which is quite big. And it's saying that it's not finding something called text, but we can use all of this. Right, maybe this is too big. Okay, let's ignore this one. Like, this is not, I suppose, a request problem. This is a serde problem. This is what I was trying to double check. It would be nice if it will tell us. Oh, WGaffa, sorry, I didn't see your comments there. So how did the raw JSON look like? Actually, let's do one thing. Let's rerun this with the raw JSON. And let's copy paste that JSON somewhere. Let's just print it not in debug mode. Right, so now we should be able to copy paste all of this into some JSON visualizer or even JQ. Okay, this is probably very small. So we have JSON, recent tracks, track, then 0. I am assuming that here we are looking for text that doesn't exist. So maybe this is the problem. Let's double check our types. We are looking for That was, where are we putting text? Okay, there is text here in album. Right, let me look at the error one more time. Oh yes, I think I understand now. Yes, so this text here, the reason why I use this row string is because I wanted to do hashtag text, but I think we need a double hashtag, which I have no idea how do you even express that. Okay, let's try to fix this by looking at if serde gives us an alias for this type. Sorry, just to explain that again. If we open, for instance, album, we have this actual hashtag text, which is the string we want to match. And I don't think we can just express an hashtag as a field type. Oh, perfect. Legend WGaffa, you are giving me the solution here in the chat, which is to just use this serde alias text. So let's do that. So we can basically remove this and do this. Why it doesn't like, oh yeah, I lost an hashtag in copy pasting this. We have that a few other times. Is that it? Yes. Okay, let's try again. Now response, we need again to give it the question mark. And was that an hashtag to pretty print? I think so. That looks much better. Perfect. This is what we wanted to do. So awesome. So at this point we do have, of course, a typed response. So what we could do is like, I don't know, let last song equal to response recent tracks track first unwrap, and then here we're just gonna print the last song, which is what we wanted to do all the way. Nice. Perfect. So here we have all these details. There is one additional thing that I might want to do, but I'll probably gonna leave that for the next session if we continue this work, which is basically, because I've used this API before, I know that there is a very tricky thing that they do, which is if you're currently listening to a specific song, the first track that you see there has an additional field that is like currently listening true or something like that. So we might be using that as another way to tell if I'm listening to something right now, or this is just the last song that maybe I listened to yesterday. But this is an exercise, I suppose, for next time, because now we are almost at time. So I'm gonna give you a few minutes just in case you have any question or anything else you might want to chat about. Of course, I'm gonna be making this example available on GitHub. I just need to make sure I ignore my M file, but I'll commit that afterwards and make the video available on YouTube and the repository available in the notes on YouTube. So yeah, this is again the link for YouTube. And other than that, you can find me on Twitter. So I'm gonna drop my Twitter as well. Yeah, and I think that you don't have any question. I hope that this was useful. I certainly learned a lot. I did learn about the dotenv crate. I did learn how to use request, at least a very basic usage, just doing a get request. I learned about the URL crate, which allows us to build, well, to parse URLs and to build them somewhat programmatically. At least in our case, we wanted to start from a base URL and add a bunch of query string parameters. Finally, we learned a little bit about Tokyo. We learned about serde-json and how to use the derive macros. We also learned, thank you to WGaffa, about the alias, which allowed us to work around that hashtag text field, and probably something we can also use if we want to parse that initial attributes block that we were getting as a response. And yeah, that's probably all about it. So I suppose thank you very much for being with me today, and I'll see you maybe next Monday. Also, full disclaimer, next week I'm gonna be at Rust Nation UK, so if you happen to be there, give me a shout. I'd love to meet you in person. So not sure if I'm going to be doing a stream on Monday, depending on how far away I am with preparing for the conference, but I might be doing another stream on Monday. So just stay tuned on Twitter, LinkedIn, YouTube. I'm gonna be mentioning something there. So thank you very much, everyone. I'll see you in the next one. Bye.